In this video, we'll solve some problems related to projectile motion, and we'll try to solve some of the more intricate ones. We'll try to see how our understanding of this problem can be applied to a few different situations. So here is a problem involving a skier who jumps uh, off of a surface at a certain angle and just barely lands on a sloped surface. So if we know the initial angle of the jump, we want to know what is the angle between the trajectory of the skier and the inclined plane, which is inclined is an angle alpha equal to 9 degrees. Okay, so that's what we want to know. And in the second problem, the skier barely jumps from the edge of the horizontal surface at the same angle and reaches a point much below. So we want to again find the angle between the landing trajectory and the inclined surface, and we also want to see how far below the horizontal surface does the skier land. So one of the things is that if the if the skier lands at an angle of phi with respect to the horizontal, and the surface is inclined at an angle alpha with respect to the horizontal, the angle between the landing trajectory and the surface is phi minus alpha. Okay, so that's understood. So one of the things to note that the 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 launch angle is the same as the landing angle because the symmetry of the problem. Okay, so what ends up happening here is that the phi is the landing angle that the skier makes with the horizontal is phi equals theta 0, and that equals 11.3. Therefore, the angle that's made between the landing trajectory and the inclined plane is phi minus alpha. 11.3 minus 9 equals 2.3 degrees. Okay, so that's the angle. So similarly, we want to find the angle in this more uh, intricate case. So here, one of the things to do here is write the equations of motion, and so we will write x here equals v0, okay, cosine of theta. So here we instead of writing theta 0, for the sake of uh, for the sake of brevity, we'll use just theta. So v0 cosine theta times t, and y here equals v0 sine theta t minus half gt square. Okay, where x is in this direction and y is positive in the upward direction. Now if we look at the inclined plane here is y equals y divided by x equals minus tan of alpha. Okay, because the slope of this inclined plane is negative, so therefore y divided by x is negative tan alpha. Okay, so here we can write we can take this thing and plug it in here. So we can write therefore um, um, or let's write it this way, uh, y equals minus x tan alpha. Okay, so let's write it this way. Okay, so therefore uh, when we divide the first one by the second one, right? So let me erase this here. Okay, let's divide number 2 by number 1. So here we get y divided by x equals v0 sine theta t minus half gt square divided by v0 cosine theta t, okay, and that is equal to minus tan alpha. Okay, so essentially that's what happens. So let's cross multiply. So we get v0 sine theta t minus half gt square equals minus v0 cosine theta t times tan alpha. Okay, so let's collect the terms. Okay, so we have half gt square, okay, minus v0 times t sine theta plus cosine theta times tan alpha equals 0. Okay, and taking t as a common factor, we will write here t times gt divided by 2 minus v0 sine theta plus cosine theta tan alpha, okay, equals 0. Therefore, so t has two solutions, 0 or t equals 2v0, that's sine theta plus cosine theta tan alpha divided by g. Okay, so essentially that's what we get. So now we now know the time of flight, okay, of the projectile, which is the skier in this case. So all we can do here is we can plug that in, okay, for x. Okay, so x equals v0 cosine theta times t. Therefore, the distance traveled in the x direction is 2v0 or 2v0 square cosine theta sine theta plus cosine theta tan alpha divided by g. Okay, and the y here is negative tan alpha times x. Okay, it is therefore it is minus 2 v0 square cosine theta tan alpha divided by g times sine theta plus cosine theta times tan alpha. Okay, so and that's how much is the distance from the horizontal. Okay, so that's the distance from the horizontal, and that is equal to h. Okay, so and h here has a positive sign, so we will take this out and make h equal to 2v0 square cosine theta tan alpha sine theta plus cosine theta tan alpha divided by g. Okay, so essentially, so that's how far below the horizontal, okay, the skier has dropped. Now the question to us is, okay, what is the angle that the skier makes with the horizontal? Okay, so here let us call this time of flight as t star, as capital T. Okay, so that will help us. So the angle that the trajectory makes with the horizontal here is nothing but dy over dx. Okay, and that is nothing but dy over dt divided by dx over dt. Okay, so dy over dt is v0 sine theta minus gt. Okay, and dx over dt is v0 cosine theta. Okay, and that should be equal to the tan of phi. Okay, so the angle that the skier makes with the surface while landing is phi minus alpha equals tan inverse v0 sine theta minus g, we put capital T here, divided by v0 cosine theta. Okay, where the capital T here, okay, equal to the time of flight. Okay, so I hope you get an idea for how to find these values. Okay? So in this problem we will look at the trajectory of a ball that is thrown from the ground, okay, and it lands on top of a building at a height of 20 meters, and it at an angle of 60 degrees with the horizontal. Its time of flight is 4 seconds, and we want to know what its initial velocity was, what was the angle at which it was thrown, and what was the horizontal distance that it traveled. Okay, so let's get into that. So we know here that y is equal to v0 sine theta t minus half gt square. Okay, so at time t equals 4 seconds, y equals 20 meters. So let's put that in, v0 sine theta times 4 minus half g times 16. Okay, we divide by 4 on both sides. Okay, so we get 5 equals v0 sine theta, okay, minus 2g. Okay, therefore v0 sine theta equals 5 plus 2g. Okay, so we have that. So now here we can also say that x equals v0 cosine theta times t, where t is the time of flight. Okay, there is no acceleration in the x direction. So now if we want to find out the slope anywhere, okay, so here the slope here is dy or dx, okay, and equals, by the chain rule, it's dy or dt divided by dx or dt. Okay, and dy or dt is nothing but v0 sine theta minus gt, and dx or dt is v0 cosine theta, and the slope here at t equals 4 seconds is negative, and that is equal to negative of tan 60 degrees. Okay, is negative square root of 3. Okay, so we know that v0 sine theta here is 5 plus 2g. So let's substitute that in. So 5 plus 2g minus 4g divided by v0 cosine theta, okay, equals minus square root of 3. Okay, so here we get 2g minus 5 divided by v0 cosine theta equals square root of 3, or v0 cosine theta equals 2g minus 5 divided by square root of 3. Okay, and let me write square root of 3 properly. So the nice thing here is that we know that v0 sine theta equals 5 plus 2g, and v0 cosine theta equals 2g minus 5 divided by square root of 3. So we can divide the two to get tan theta, okay, is 5 plus 2g, okay, times square root of 3 divided by 2g minus 5. Okay, and theta is tan inverse of that quantity, 5 plus 2g times square root of 3 divided by 2g minus 5. Okay, so and also the v0 is pretty simple to compute. Okay, v0 is v0 sine theta square plus v0 cosine theta square, and we take the square root of that. Okay, so I will leave these values as an exercise for the viewer. Okay, and now that we have found V0 cosine theta, so the, uh, the, the time of flight is also known. So therefore, the range, the distance d here is V0 cosine theta times t. V0 cosine theta is 2g minus 5 divided by square root of 3, and t is 4 seconds. And so this in meters, okay, will give you the value of the distance traveled. Okay. So this is a relatively simple and straightforward problem. Okay, provided you use the calculus to solve this. Okay, okay. So let's look at yet another problem. Okay, so here we have a situation where we have a ball. Okay, that is thrown next to a wall. Okay, and it is thrown at a height of 1 meter, and it is caught at the same height. Okay, so here it arrives at point A after 1 second and arrives at point B after a total of 5 seconds. Okay, and here the distance d is known to be 50 meters. Okay, the distance d is known to be 50 meters. Okay, so we want to find out, okay, what is the distance traveled, the total distance traveled by the ball from when it is thrown to when it is caught. Okay, okay, we want to find the magnitude of the velocity, the angle theta. Okay, and so these are the three things: the horizontal distance traveled, the velocity, and the angle theta. So given these parameters, okay, so let's look at this. So now here the distance traveled along x equals v0 cosine theta times t. So at a, x of a is nothing but v0 cosine theta times 1, and at b the distance along x here is v0 cosine theta times 5. So xb minus xa is essentially 50 meters. So v0 cosine theta times 4 equals 50. Therefore v0 cosine theta equals 50 divided by 4, that is 25 divided by 2. Okay, so that's pretty simple to do. Okay, so now the thing is that what else can we compute? Okay, so we know here that the y at here equal to the y there. So we know that. So y equals v0 sine theta t minus half gt square. Okay, so y at a equals v0 sine theta. Remember that t is 1 here, minus half g. Y at b equals v0 sine theta times 5 minus half g times 25. Okay, so since the two are the same, okay, we can write v0 sine theta minus g divided by 2 equals v0 sine theta times 5 minus g times 25 divided by 2. Okay, so we rearrange things. We get 4 v0 sine theta equals 25 minus 1 divided by 2 times g. So v0 sine theta equals 24 divided by 8g equals 3g. Okay, so now that it's pretty simple. Again, you can find, since v0 cosine theta equals 25 divided by 2, 25 divided by 2, and v0 sine theta is 3g, right? So we can divide the two to get tan theta. okay, is 6g divided by 25, and theta equals tan inverse 6g divided by 25. Okay, and v0 is nothing but v0 sine theta square, okay, plus v0 cosine theta square. We take the square root of that. Okay, so that's pretty simple. Okay, so now we want to find the total, the r. Okay, so we want to find out r. So when to find out r, we want to know the time of flight. Okay, so y equals 0 in both cases, right? So therefore v0 sine theta t minus half gt square equals 0. So we factor out t, v0 sine theta minus half gt equals 0, which means that t equals 0 or t equals 2v0 sine theta divided by g. Okay, so to find r, okay, we've just said we set r equals v0 cosine theta, okay, times t, where this is the value of t. So we plug that in, so and we get v0 square sine 2 theta divided by g. Okay, so and so we know v0 here. So v0 is known, theta is known, g is known, so we can find out r. Okay, so I hope this will convince you that these problems are not difficult, and they just need to be attacked in a certain way, and they just need to be thought through in a very elegant and a simple manner. And I hope this will give you a good understanding of what projectile motion actually means. So if you like this video, please click on the like button and subscribe to this channel for further updates. Thank you.